Hello, today I'm going to tell you about rational and irrational numbers. This is an important understanding for just like knowing the sets of all numbers that there are. Numbers can be categorized in lots of different ways, but one way that we do it is talking about rational numbers versus irrational numbers. And rational numbers are the ones that we're mostly used to. They're ones that can be represented as a ratio, right? The word rational has the word ratio right in it. So if we're talking about rational numbers, they're ratios, which means really that you can represent them as a fraction. So here are the different kinds of rational numbers that you can think about. There are integers. Integers are, your favorite thing, like 7 is a rational number because I can represent it as a ratio, 7 over 1, or negative 8 over 1, and so on. You also have fractions, which obviously, right? Fractions are just ratios, so anything that you can represent as a fraction, 1/2, negative 7/8, and so on. A really important one, though, is any terminating means it stops, right? Terminating decimals. Terminating decimals can always be represented as a fraction. For instance, 0.5, that's 1/2. Or 3.71, well, that's 371 over 100. So those can obviously be represented as a fraction. And you can do this no matter how many decimal places it goes. If the decimal stops, then you can represent it as a fraction, therefore it's a rational number. Another way that you'll see them, it's kind of a trick, but roots of perfect squares are rational. And like I said, it's a trick. It's just a way to get you to think like, is this rational or not? Because, for instance, the square root of 64, well, that's plus or minus 8, or the square root of 0 is 0, and all of these are rational numbers. So you'll see that sometimes when you'll see a list that says, choose the rational numbers, and they'll give you some square roots in there. If it's a perfect square in there, you know that it's a rational number. Or you could do the roots of, cube roots of perfect cubes. The cube root of 27 is 3, and so on. But then finally, another one that's really important to know about are repeating decimals. All right. Repeating decimals. And you know what these look like, because you know that I can't even remember the name of it. I should look it up. But the like 0.33 repeating, that's 1/3. Or 0.22 repeating, that's 2 over 9. So repeating decimals can always be represented as a fraction. In fact, there's a way to prove it, and I'm going to do that now. So let's say we wanted to prove that let's pick a different one, 0.44 repeating could be represented as a ratio. So I can say that this repeating decimal, I'll just set it equal to x, because that's useful sometimes. And what I want to do is I'm going to multiply this by 10. This entire equation I'm going to multiply by 10. I'm going to, because by doing so, with any decimal, you just move, when you multiply by 10, you move the decimal point one place over. So this 0.44444 infinitely would be 4.44444 infinitely. There's an infinite number of 4s, so we've just moved the decimal in front of the first one, and that would equal 10x. Okay, so now what I'm going to do is I'm going to subtract 1x from each side. But on the right-hand side, I'm going to represent x as x. And on the left-hand side, I'm going to represent x as 0.4 repeating, like this. Right? Because these are equivalent values. 0.4 repeating is equal to x. So I can do that. And I end up, the neat thing is every 4 in the decimal place, they cancel out. And what I get is 4 equals 10x. 10x minus x is 9x. I don't know if students heard, but my son went poop and he needs a butt wipe. Okay, so I'm going to divide by 9, and there. Now I can show that x is the same as 4/9. Okay, and you're going to be asked to do a few of these where you take repeating decimals and turn them into fractions. But then irrational numbers, well, they're a little bit easier to spot. There are 3 kinds of irrational numbers. there are special numbers. So these are special numbers. I should maybe call them special constants. But so yeah, I'll add that word. These are constants. Okay, so numbers like pi. Pi is irrational, as you know. It's 3.1415926535897932384 Oh gosh, 433832795028884. Yeah. You see that written as like this sometimes, 3.1415, and then you'll see a dot, dot, dot. Or there's E as a special number, and E, I can't even remember, it's 2.81 or something, maybe